My name is Harjinder, Sandhu. I'm the CEO of Sakera. I'm going to talk to you about voice AI in medicine, both the past and the future. But I'm going to talk about voice in a particular context. Most of the time these days, when people think about voice, both in medicine and beyond, automatically they begin thinking about applications such as Alexa or Siri, which are conversational agents. You express short utterances and they respond, answer questions, and so forth. The context in which I'm going to talk about is the clinical context between doctors and patients, where conversational agents actually don't work. You actually need a different form of voice in order to capture what goes on in the context of that kind of encounter. But let me back up to when this all began. So long ago, the dark ages of computing, physicians used to do dictation. And they did a lot of it. Most physicians back 20 years ago did dictation in order to capture clinical notes. And for the most part, what you had was transcriptionists sitting in the basements of hospitals, basically getting the recordings and typing up those dictations. Back then, this was considered to be a $20 billion or so industry. $10 to $20 billion is what people used to peg it at. And it was a fairly efficient process for physicians, but of course, it was a very expensive process. And so what a lot of people started thinking about how to incorporate voice recognition into that process. And what happened is actually a lot of advancements in voice recognition actually happened in this context, where we started capturing, my company that I started long ago, others were starting to think about this as well. We started capturing a lot of this voice dictation that physicians were doing, and we inserted speech recognition into the process between the physician and the transcriptionist, and we were able to bootstrap speech recognition based upon what we learned from what the transcriptionist was doing. And this was a remarkably efficient process in terms of learning how to bootstrap a speech recognition process. We were able to go from what I would say about 20% accuracy for this space, which was useless back in 2000, to eventually getting this up into the high 90s in terms of accuracy, and all predicated on gathering millions of dictations, passing them through a voice recognition engine, sending them to a transcriptionist, and basically going on from there and improving the voice recognition system. What happened? In the last decade or so, every health system started implementing electronic medical record systems, and they basically told the physicians, well, you can't do dictation anymore. You have to enter data into the electronic medical record, into the EMR. And it turns out that classical, traditional speech recognition systems aren't very good at helping you in the EMR process. Now, you can still do narrative. You can still dictate these paragraphs, because that's what speech recognition engines were designed for. But it really doesn't help you with all the little checkboxes and the pull downs and all the discrete data that you are trying to enter into the EMR. And so what ended up happening is most physicians actually started just typing directly into the EMR. And what you found was a lot of misery. And that continues to today. So when you talk to most physicians, what's your biggest challenge in terms of your work environment, life as a physician? Well, they'll probably tell you physician compensation is the number one thing. But not too far behind that, they'll say, well, the EMR is my problem. I spend way too much time typing into the EMR and trying to just close charts and write up notes and things like that, entering orders, entering diagnoses, allergies, medications, all that kind of stuff. And most of the studies that have been done say that typically for a physician that spends 1 hour of time with a patient, they're spending about 2 hours looking at a screen. And so it's a massive problem. And this is the context, again, in which when we think about speech recognition, voice recognition, it's in this context where you can't really use a conversational agent. How do you capture a lot of the data that needs to be captured in the context of a doctor-patient visit without actually getting in the way of that doctor-patient visit? You already have screens that are getting in the way of that visit, and we're trying to eliminate those screens. And a lot of people are trying to think about, well, how do we change the tenor of this visit so that doctors can focus back on the patients? So again, to give a little bit of context to this, voice generally comes in two flavors today. And just to get a sense of how people are thinking about this in medicine, I generally tend to think of these as, on the one hand, voice assistants. These are these conversational agents, which today are relegated to very simple kinds of interactions. So you can say a sentence, a very simple sentence that the system can understand, whether it's an Alexa or Google Home or something else, and it'll respond, and then you can say something else and add to it. But you can't use that kind of a framework for capturing long-form information. You can't, for example, expect a doctor is going to sit there, a doctor that would normally generate a document for a particular patient visit that may span 2 or 3 pages. They're not going to interact with a system this way to actually capture all this information. At that point, they may as well just go back to typing this all up. And so the other form, which is now the subject of a lot of work by us and by many others as well, both in academia and industry, is how do we create systems that can passively listen in on doctor-patient visits and extract from those visits what is meaningful in terms of documentation. And so think about the complexity of just these simple interactions with Alexa, which are these simple statements that you make, and the NLP that you need to extract information from those simple interactions, and now expand that to the full spade of what doctors and patients can be talking about. It's an incredibly difficult challenge. But this, I would say, among all the forms of voice that are being worked on today, that are being implemented, this has both the greatest opportunity, it's the greatest challenge as well, but it's the greatest opportunity because what's limited electronic medical record systems today from being actually useful. So people implemented EMRs with the idea that they were going to be useful in a clinical context. Originally, most of them were designed specifically for billing, but most of the implementations that large health systems did were with the idea that, well, if we had all the information that we need in the EMR can help us with all sorts of, it can help us improve care. It can alert us when we're trying to enter a drug that the patient has an allergy for. It can start helping us in many different clinical ways. And yet this never happened largely because the data isn't actually being entered. There's too much work for a physician to try to enter all this data. And so the idea of an AI scribe has basically been, well, listen in on that conversation and try to capture what's happening so that we can create data automatically. As I said, a very difficult problem, but one that is being realized and is going to actually become the de facto way in which documentation in the clinical setting is created. So where is this headed? AI scribes, voice assistants, and again, this is my terminology. I tend to think of these two as kind of different types of technologies, very different technical frameworks, technical paths, which are ultimately going to converge. But ultimately, what they're going to converge into is something beyond either of them. What's going to happen, what's happening already, and we're starting to see the very first signs of this, is that in a clinical context, these simple systems, the voice assistants that can answer simple queries such as pull up the latest lab results for this patient, or AI scribes, which are just trying to listen on that conversation and capture data in a very passive way, that these are going to be replaced and ultimately merge into what I refer to as AI clinical assistants. And AI clinical assistants are basically an idea that these systems will evolve to the point where they don't just passively react to simple queries or try to understand conversations, but what they will actually do is participate and eventually transform the process of care. So as an example, if a patient is coming in to see a doctor, a AI scribe is just going to listen in and try to document that care. What a clinical assistant would actually do is to say, well, I'm going to prep that chart for the physician. I'm going to give you a summary of what you need to know about this patient already. I'm going to tell you what the care gaps are for this patient. So this patient happens to be over 50 years old, hasn't had a colonoscopy, is due for a colonoscopy. This other patient is 65 years old, is coming in, has a history of hip fracture, should be screened for osteoporosis. These kinds of features are what makes this a true clinical assistant, and this is the future. This is where all these voice technologies are converging, and it's more than just voice. Obviously, there's other components to this, but eventually what's going to happen is that the physician themselves is going to be augmented by a clinical assistant, a AI-based clinical assistant that will have both voice interfaces as well as screens when necessary to display a lot of data, and they'll actually be, as I said, transforming the process of care. This is going to happen over the next couple of years, and we're beginning to see the first hints of this today. Thank you.